There's two. They're like uploading on the thing right now. Hmm.
Is it going slow for you too?
Yeah, a little bit.
Yeah, I don't know why it's so slow tonight. It's super slow for me too.
Mm. Mm. See if I just download. I just got a new phone, so my phone's like been. It's like trying to get used to. Okay, let me know if I can see it. Mm.
Yeah, I got it now.
Okay, that's the first one. I put the second one. Okay. Are you able to like rotate it? It like won't let me.
Yeah, I can do that.
Okay, okay. Thank you.
All right. It says number one says, what is the largest possible area of a right triangle whose hypotenuse is that? All right, so the area of a triangle is 1/2 base times height,
Mm-hmm.
right? So
Mm-hmm.
let's take our triangle. It's a right triangle. So we know that this is the base and this is the height. And the only thing we know is the hypotenuse, which is 5. So let's use these. Let's basically here's the idea for optimization problems. You want to take your formula you're trying to optimize and you want to rewrite it in terms of only one of the variables.
Okay.
Okay. So we have to find some other equation that relates B and H together. And the fact that the hypotenuse is 5 centimeters long, we know the equation is Pythagorean's theorem, which is H squared plus B squared equals 5 squared, right?
Yeah.
So let's solve that for H. So H equals the square root of 25 minus B squared. Got how I got that?
Yeah.
Okay, we know it's not the negative one, so it's just the positive one of that. So now let's plug that in for H. So we know area in terms of B is going to be 1/2 B times H, which is really the square root of 25 minus B squared. Got it?
Okay.
So now
Yeah.
to optimize this is just going to be, we're going to set this equal to 0. That's the optimization is going to be where that equals 0. So
Mm-hmm.
um, set that equal to 0. So it's 1/2 B times the square root of 25 minus B. Whoops, I did that wrong. My bad. I did that wrong. I have to first take the derivative of
Derivative.
this.
Yeah.
Yes, thank you. The derivative of this, which is going to be, let's just use the product rule. So it'll be 1/2 B times the derivative of the inside thing, which is 1/2 to the negative 1/2. It's 1/2 25 minus B squared times, I'm using the um, chain rule, times 2B.
Mm-hmm.
Got it? So I took the
Mm-hmm.
derivative, I'm taking the derivative of this. So I take the derivative of the outer function, which is a square root. So it's 1/2 and then to the negative 1/2 of
Mm-hmm.
that thing left untouched. And then I multiply that by the derivative of the inside, whoops, which is not, it should be negative. It should be negative 2B. Got it?
Yeah.
Plus, remember, this is the power rule, plus 1/2, because that's the derivative of this. It's just 1/2 times
Mm-hmm.
the square root of 25 minus
25.
B squared. Got how I did that?
Yeah.
Okay, so this equals, so now I'm going to set this equal to 0 because I'm trying to maximize this. So let's simplify this a little bit. So the 2's are going to cancel. I'm going to have on the top, I'm going to have a B, I'm going to have a negative B squared on the top because B times B is B squared. And on the bottom, I'm going to have a 2 and a square root of 25 minus b squared.
Wait, where are you getting the 2 from? Oh,
Uh,
from that
there's
animation.
the 2. Yeah,
Yeah.
that negative power means it just goes to the bottom,
Hmm.
right? And then that's plus the square root of 25 minus b squared all over 2. So that's my equation, and I'm trying to find out where that equals 0. So the easiest way to do that probably is just to get common denominator. So I need to multiply this by the square root of 25 minus b squared on the top and the bottom. Got it? That way I'll have the same denominator. You follow?
Hmm.
So on the top, I have negative b squared
Hmm.
plus 25 minus b squared all over 2 times the square root of 25 minus b squared.
Hmm.
Got it?
Hmm.
And that equals 0 only where the numerator equals 0.
Hmm.
It's undefined where the denominator equals 0.
Okay.
So negative 2b squared plus 25 equals 0, which means b squared equals 25 over 2. So b equals the square root of 25 over 2, which is 5 over root 2, or 5 root 2 over 2.
Okay.
So that's your height. No, that's your base. That's your base. And now to find your height, you just plug that in to the equation and solve. So plug this in for that b, squaring that. So that's going to give you 25 over 2. So h squared plus 25 over 2 equals 25. Just the black so I can see that. So it's the same thing basically. H and B are going to be the same. It's going to be an isosceles. It'll be this. This is going to have to be 25 over 2 as well.
The H squared
H squared
or H squared.
has to be
Mm-hmm.
25 over 2, which means H
H.
has to be this. So H and B are both the same.
Okay.
H equals B, which equals 5 root 2 over 2.
Hmm.
See how we did that?
Yeah.
You have the answer key for this, by the way?
No.
Okay.
She's
Pretty
not
sure
getting
that's right.
tested tomorrow.
Yeah, I think that's right. So for this one, rectangular plot of farmland will be bounded on one side by a river. So here's a river, and here's a rectangular plot of farmland. So we've got X and Y, let's call it. So, and it's only bounded on 3 sides. We have 800 meters of wire, so that's your perimeter. 800 equals 2 X's plus 1 Y, right? That's what we have to work with. We have 800 meters of wire, and they want to know what the largest area. We're trying to optimize the area. Area is X times Y. So same deal, right? We're going to try to simplify one of these, or
Hmm.
solve this for X or Y, plug it into there, and then take the derivative and then set it equal to 0.
Hmm.
Okay, so this one's actually a little bit easier. So Y equals 800 minus 2X. So A in terms of Y, I'm sorry, A in terms of X is equal to X times 800 minus 2X. Got it? So A of X equals negative 2X squared plus 800X. And by the way, you don't even need calculus to do this. If you wanted, you could just find, this is just an upside down parabola, right? So you remember how to find the vertex of a parabola? You know that's going to be the highest, the largest area.
Yeah.
Negative b over 2a, that's your x value. So negative b is negative 800 over 2a. So that's just, what is it, 200?
400, 400. Oh, wait. Oh, no, 200, 200.
Yeah, 200. So x is 200, and that would mean y is 400, right? When you plug it back in. But let's do it the calculus way now. So the derivative is going to be negative 4x plus 800. And now we'll solve that for set that equal to 0 and solve it. So 800 divided by 4, just like what we had before, it's 200. So 200 feet, was it? Meters. 200
Uh,
meters is your x. And plug in that, whoops, plug in 200 for your x up here. You get 400, you get y equals 400.
I just have a quick question. Where it says underneath the a equals xy and you got ax equals x parentheses x minus 2x. Where did you get that from? Like, how
800
did
minus
you,
2x?
like, did you just, like, factor it out, like,
No, so
the
look at right up here. I want to
hmm
solve it for either x or y. Which one would be easier to just get by itself, x or y?
y?
Yeah, so I just solved it. I just moved the 2x over.
No, yeah, and then it's underneath, like, the a x y, like,
This right here.
yeah.
Or so then what I did is I plugged in y. What does y equal?
Oh, 800. Oh, okay, okay, okay.
800 minus 2x. Yeah.
Okay, okay. That
Make
makes sense.
sense?
I just needed like a re-explanation of it because
Yeah.
in class it just didn't really make sense.
Yep. Got it.
Um,
You have another one for me?
that was really it. The rest of them we had done in class, but those were the two I was just kind of confused about. But
Okay. So
I got the
just
rest of
again
them.
to reiterate what you want to do is you want to come up with your optimization equation, right? That's the one
Mhm,
that you're trying to maximize. Largest
mhm,
area, that's a typo. The largest area, and then you have to have another equation. Usually you have to find another equation that relates those two or more variables together so that you can find the area in terms of only one of the variables so that you could then take the derivative and set it equal to 0 and solve for that one variable.
okay.
So that's how we do it. Sometimes you have like a common one you'll see is like there's a ladder sitting like on the side of a building and it's moving that way and they're talking about the angle here
Hmm.
and you got the length of the ladder and stuff. So then you would need trig for that because trig equations relate angles to side lengths, right? So I've seen that.
Yeah.
That's a harder one that I've seen sometimes before. I've seen ones with like volume of a volume of like grain going through a silo or something, or there's a hole. Maybe there's like a bucket or something like that, a pool, and there's a hole with water coming out. And you're trying to put water in, and the rate going out and coming in, all kinds of crazy things. But the point
Hmm.
is you always need to just find the formula, find your formulas that give you your variables that you're looking for, and then plug them into your optimization problem or equation. So this they wanted me to optimize the area, so I knew the area equals x times y, and I had to find out how x and y are related. Well, they're related because you have only 800 meters of wire. So is the
800.
perimeter is x plus y, right?
Yeah.
For this one, the area, they wanted us to maximize the area, but they also told us that it was a right triangle and there was a hypotenuse of 5 meters always. So these two things change. That's why they're variables. Five always has to be five. So then you just set up your equations, think, well, how can I relate h and b and five? Oh, yeah, 1/2 base times height is your area of a right triangle.
Okay.
All right. Make
Yeah,
sense?
that makes sense. Yeah, thank you.
Yeah, no problem. Hopefully I'll see you tomorrow. If not, you can send me some
Mhm.
questions. All
How
right.
on Wednesday, how long are you there usually on